Okay, so good evening. We'll get going. Let me first, on behalf of Asset Colloquium, would like to welcome Professor Mallik, Professor D.C.V. Mallik, formerly with Indian Institute of Astrophysics, Bengaluru. Also, it's great pleasure for me today also to kind of warmly welcome his son, Dr. Prof. Mallik. It's Mallik? Yes, okay. Who incidentally is also an astrophysicist. His PhD is in astrophysics. And right now he's also engaged, taking up a big outreach initiative from Raman's own hub, Raman Research Institute. And I wish you could have heard from you as well on your initiative and, how taking science to the schools, etc., and not just only lectures and so on, but actually, hands-on building things by their hands would have been very interesting topic. Maybe we'll reserve that for another day. And when I say another day, maybe we should also reserve another day for Professor Mallik's daughter-in-law, Sugandha, who is an accomplished Hindustani classical singer. We also have a forum called AMA, Amateur Music Association, which organizes such programs, not here, but it's in the auditorium foyer, you would have actually seen. So today probably we'll have 2 more such programs to coming up. Okay, on that nice and happy note, we would like to thank, of course, Professor Alakre, who actually made this today's program possible. Without taking more of your time and the speaker's time, let me invite Professor Alakre to formally introduce today's speaker. Yes.
Thanks, Satya. It's a great pleasure to welcome Dipankar Chandra Bosu Mallik. I know him for a very, very long time, from my childhood. He used to be great friends with one of his classmates who was a neighbor in Calcutta. And I would see him walking in the friend's garden, deeply engaged in discussions with that friend. And that friend was also very well regarded because he was a well-regarded physics student in our school. In fact, I have some commonality with Dipankar that he and I went not only to the same college, but also to the same school, which is Baliganj Government High School. And we later also went to Presidency College. I am several years junior to him. He's actually a classmate of my brother. And then later on, many years later, I found that there is this gentleman in Indian Institute of Astrophysics who I happen to know from my childhood. It took me a long time to actually connect that these two are the same individual. But anyway, Dipankar, after graduating from Presidency College, he went for his master's degree in Calcutta University. And after that, he had been to University of Wisconsin at Madison. He has a very famous advisor, Dr. Osterbrock, and many of you have actually known about his AGN and AGN book, Astrophysics of Gaseous Nuclei and Gaseous Nebulae and Active Galactic Nuclei. I happened to meet him actually in UC Santa Cruz, and we exchanged notes that I know your student. Anyway, so Dipankar has researched for many years in the Indian Institute of Astrophysics on planetary nebulae and interstellar medium. He's also an avid teacher, and towards in 1990s, he developed a strong interest in history of science. And he has written this very important and wonderful book about Krishnan, which is filled with a lot of anecdotes and data. And we are looking forward to hearing from the speaker himself about about Dr. Krishnan and his work and his life and work in the post-independence India. Dipankar. Thank you.
Why? Because thank you. Okay.
Better audio for the online.
Oh, yes.
You can see that there are a number of people on the Zoom call.
Oh, wow.
And also on the YouTube. You don't see YouTube here, but I can see.
Okay. Thank you very much for inviting me to give this colloquium at ACT series, Dr. Satyanarayan. I must also thank Alok for prevailing upon Dr. Satyanarayan to extend to me this invitation. This talk is dedicated to the memory of my very dear friend, Vijayaraghavan Thiruvadi, custodian of S Krishnan papers, who very suddenly passed away on August 1st last year. But he had done his last duty to his grandfather, S Krishnan, by depositing all his papers, notes and everything to the archives at the NCBS in Bangalore, where they are now being digitized and will soon be, in a few months, open access all over the world. So that's a wonderful thing that he did. Now, I begin with a very provocative remark, for which I may be excused. The so-called Raman effect was discovered by Karyamanikam Srinivasa Krishnan in 1925. And for whatever reason, he never got due credit for it. In a testimonial that Raman himself wrote in 1932 to the Andhra University, where Krishnan had applied for a professorship of physics, he said this: based on the record of the year 1928 alone, instead of the entire work on the scattering of light done at Calcutta from 1921 onwards, Krishnan would in justice have come for a share of the prize. But this statement conceals more than it reveals, and Raman was being disingenuous, because Krishnan's engagement with scattering of light started the year he joined Raman's laboratory, the Indian Association for the Cultivation of Science, in 1923 itself. And this paper came out in 1925. The paper that I'll be talking about came out in 1925 in Philosophical Magazine, and it was communicated by none other than C.V. Raman. So let me first say a few words about Krishnan's early life. He was born in a small village called Virupanur in Ramanathapuram district of Madras Presidency in 1898. And he went to school in the neighboring temple town of Shivilliputtur and Hindu high school there, graduated from there, then went to American College, Madurai, graduated from there, and then went to Christian College, Madras, where he graduated in 1918 with a bachelor's degree. Now, Christian College time, or even earlier, he had developed a lot of interest in science, particularly in physics. And when he went to Christian College, he made it a habit of visiting Connemara Public Library, which many of you may know, which is a collection of journals. And there he used to leaf through Royal Society journals, Philosophical Magazine, Nature, etc. And he came to realize that some Indian names were very much prominent. Of course, Srinivasa Ramanujan had just then returned to India, but he was terminally ill. The second name that became very prominent in those journals was one C.V. Raman, Chandrasekhara Venkata Raman, who did work in a little known place called Indian Association for the Cultivation of Science at 210 Bawazar Street. And his papers regularly came out in Philosophical Magazine and Royal Society journals on vibration of strings and membranes, and some early papers on diffraction and scattering of light. So every student in Christian college or in any college in Madras aspired to be working with Raman someday. Now, Krishnan's first offer of job came to from a very different quarter. In 1918, I don't know how many of you know, after the soldiers returned from the war, they brought some virus which was raging through the world. It's like COVID, but much before. A lot of research is being done on this now. It's called the Spanish flu. And that killed about 5 million people in India. I know of several well-known people who died in that. Aurobindo Ghosh's wife, Mrinalini, died in that. One of Raman's nieces died in that, so on and so forth. Kodaikanal Observatory, of which John Evershed was the director, lost its second assistant, one Nagaraja Iyer, who succumbed to this flu. And there was an opening. And Evershed was on the lookout for a person to take that place. Now, in Christian College, there was Reverend Alexander Moffat, professor of physics, who took an enormous liking to Krishnan. And he was a great friend of Evershed's. So he told Evershed, why don't you take this guy, just fresh out of college, a lot of enthusiasm. So Evershed, sure. And he sent Krishnan an offer. Krishnan was then a demonstrator in chemistry in Christian College. Krishnan jumped at it. He accepted it and was ready to come. But then there was a problem. In Madras Observatory, which is part of the Kodaikanal Observatory, under the India Meteorological Department, there was a guy called Chidambara Iyer, and he always had a thing that if he got a chance, he would go and work with John Evershed. So when he heard this, he also sent, not to Evershed, so Sir Gilbert Walker, that I want to work with Evershed. Gilbert Walker was the DGO, Director General of Observatories, sent a letter All this I discovered during my research. Sent a letter to Evershed saying, hey, John, get this guy to your place. And then Evershed had a problem. He had already offered Krishnan. So Evershed told Moffat, I'm deeply embarrassed this problem. So what do we do? Will Krishnan take the place in Madras? And with Chidambara Iyer will vacate, and I'll immediately get him to Kodaikanal once another vacancy opens. Krishnan said, thank you, sir. I know what work Madras Observatory does. It's routine work of recording rain and recording temperatures. He packed up his bags and took the first train possible to Howrah and then to Calcutta, and appeared at the gate of the Indian Association for the Cultivation of Science to work with Raman.
Without contacting him?
Without contacting him, he just arrived. Raman was lecturing MSc classes in the university as Pali's professor, and Dr. Ashutosh Dey, who we call Ashu Babu, said, just wait, professor will come and talk to you. So then Raman came and said, well, you must first enroll in the MSc classes of the university. We're just starting. And only after 2 years of training, I will accept you as a scholar. The University College of Science had a star-studded faculty, which the rest of India has not seen ever since. It had on its faculty M.N. Saha, C.V. Raman, S.N. Bose, S.K. Mitra, D.M. Bose, so on and so forth. The Saha left just before Krishnan arrived on a fellowship to England, and he was away. But all the rest were there, and Raman had S.N. Bose as a teacher for about a year. Krishnan had S.N. Bose as a teacher for a year. Then S.N. Bose left for Dhaka. So Krishnan studied for 2 years, but he never appeared for the Master of Science examination. And he just went to Raman saying, I've finished, now you take me as a student. So that was 1922-23. Actually, formal appointment was 1923, but 1922 onwards, he was there at IACS for 1 year. 23, he got a Palit scholarship. And then 25, he became a regular employee called a research associate.
So he joined Calcutta University in 1951?
20. 18 to 20, he was in Madras as demonstrator in chemistry. Now, everybody knows, I don't know how many in this audience, but Raman's interest in scattering of light started when he was returning from the Congress of Universities of the Commonwealth in 1921, which was held at Oxford. Sitting on the deck of the ship, he noticed the so-called sapphire blue of the Mediterranean Sea and was very impressed. And what caused this color? It can't be the reflection of the sky, because even when the sky was cloudy, he found the color of the water a deep blue. So he realized it had to do with the scattering of light, the water molecules. So soon after he returned to Calcutta, he started work on this. And his first assistant was K.R. Ramanathan, who had arrived from Kerala to do a doctoral degree with Raman. So he was there. And Ramanathan started on this with some samples collected in Bay of Bengal and Arabian Sea and so on and so forth. However, Ramanathan noticed that when you have light scattered in this liquid, which is always held in a bulk, There was, in addition to the usual scattered radiation at the same wavelength, which is, we call it coherent scattering, there was radiation of a different wavelength. In fact, radiation of a wavelength of which is less than the wavelength of the incident light. And they worried maybe impurities, maybe something else. They called it feeble fluorescence, left it at that. And then Ramanathan left Calcutta after getting his degree, and he was employed at the University of Rangoon as an assistant professor of physics. So at this stage, Krishnan entered the picture, and his and their interest was to study two particular effects of scattering, because scattering is caused by density fluctuations in the fluid. So that was the first thing. And the other thing was the molecules, if they're non-spherical, if they're anisotropic, then that will have an effect on the scattering. So there was theory, and where is my thing here? So this was the very simple arrangement that Ramanathan himself had set up, and Krishnan perfected it, is what they did. S is the source is sunlight, and it's an arrangement which has been now wiped out by history. In the door to Raman's laboratory, there was a small opening, and sunlight was let in through that. They had an heliostatic arrangement so that sunlight could be, for a longer period of time, come through that door, and then it'll arrangement of lenses which will collimate the beam, a 20 centimeter focal length, and will go through a filter. Filter could be blue, orange, or green. Again, I'm told that these filters are also some combination of liquids, liquid filters. So, and then you have the scattering liquid, and again, some combination of filters and a spectroscope. So that is the arrangement. And they're watching the transverse scattering of the incident beam. The incident beam, after the transverse scattering, is completely polarized if the incident beam if the liquid is spherical, consists of spherical molecules. And this is a formula given by Einstein and Smoluchowski, which they verified. Now, if and that scattered beam is totally polarized, totally. But the anisotropy of the molecules, because of their shape, introduce some kind of depolarization effect, and this is what they were studying. And with various combination of filters, blue usually the incident beam, and then blue in the scattered beam, and then change the blue to orange and green to see if there are other wavelengths present in the scattered beam. So this was the arrangement. In 1924, Raman was awarded the fellowship of Royal Society, and he went on a long tour, and he was invited to meeting in Canada, Toronto, a meeting of the British Association for the Advancement of Science. Now, in 1923, Compton scattering was discovered, and Compton scattering is, again, scattering of photons, or, well, photon word was not that common there. Compton scattering is, again, X-ray beam is incident on some atomic substance, and you find a scattered X-ray beam which is of lesser frequency, because part of the energy is imparted to an electron which is ejected from one of the inner shells of the atom on which the... So this was Compton scattering. And in Toronto, in this meeting, there was a debate between Compton and one William Duane of Harvard University. And Duane's point was, what your interpretation of Compton scattering on the basis of quantum hypothesis is all rubbish. All this can be easily explained by the wave theory of light. And Raman joined Duane in rubbishing Compton, and he said, you are a good debater, but the truth isn't in you. And this is recorded in this very good book called Compton Effect, The Turning Point in Physics by Roger Stewart. It is there. So Raman was against the interpretation of quantum hypothesis in explaining the Compton effect, but he was quite enamored by the fact that wavelength of a different kind appeared in the scattered beam. And if this is possible for X-rays, why not possible for light? While Raman was away, Krishnan undertook all by himself the study of about 60 liquids, which he purified to the extent possible then, and studied all of them using this arrangement, and see both the depolarization and the characteristics of the scattered beam. And this paper which came out, he wrote this. How this would influence the polarization? Example, consider the case where the blue region of the spectrum excites a fluorescence in the green. Now, fluorescence is never polarized. Fluorescence is spherically symmetric emission, so it's not polarized. With the blue filter in the path of the incident beam, scattered light would be mixed up with the fluorescent light, and if we assume fluorescent light is unpolarized, the light observed would show an abnormal imperfection of polarization. Transferring the blue filter to the path of the scattered beam, imperfection would become normal because this fluorescent contribution would go off. If instead of a blue filter we use a green filter, normal polarization would be observed. And when the filter is in the path of the incident beam, an abnormally high polarization in the path of the scattered beam, because this additional so-called feeble fluorescence is added to it. In my opinion, this is Raman effect. It was stated in 1925 in Philosophical Magazine. Now I do a fast forward, and this is a diary that Krishnan kept for 3 months, 1928, from 5th February to sometime in March or April. And they're continuing the same experiments and saw this. It's exactly what he had found in 1925. And he says, when he transferred the green-yellow combination also to the path of the incident light, he couldn't detect a trace of the track. He's very much excited and repeat, this is Raman, several times. It was an amazing result. One after another, a whole series of liquids were examined, and he wondered how we missed discovering all that 5 years ago, actually 1924, when Krishnan's experiments, that is just a minor thing. 4 years ago it should have been, but 5 years ago. So this is what Raman says. Now, in 1927, Krishnan put in a string of papers together, again, encouraged by Raman, and he sent it to University of Madras to get a master's degree by thesis. And he was awarded the degree in a short time.
Excuse me. He wondered how we missed. It's Raman who wondered.
Oh, right. On February 16, 1 week after this, they sent a joint authorship paper to Nature, which is called A New Type of Secondary Radiation. And on February 28, Raman and Krishnan decided to further restrict the range of wavelengths by using some uranium filter, uranium glass as a filter with the other combination of filters to cut down everything beyond the blue region, and studied in several liquids the scattered beam, and they found, to their utter surprise, that the original scattered beam, which is of the same wavelength as the incident, is separated from another set of scattered beam by a dark space. Obviously, it is at a different wavelength. And this spurred them on to use monochromatic light. And they had a Mercury arc, where we have this very prominent line in 4358 angstroms, and they managed to get this very strong line. In fact, they say you can read in Mercury line or Mercury light in Los Angeles because of the fluorescent lighting of the entire city. So it's a very strong line. So that line was used to study spectrum, scattered spectrum of the fluid. And I don't know, it was in the afternoon of February 28th, and they found that the scattered beam had the usual Rayleigh line, but there were additional faint lines in the red. So it was late in the afternoon when Raman effect was discovered, and next day, it was released to the Associated Press. Now, Raman effect is the following. You have an incident radiation, the ground level N, it goes to a virtual level R and immediately de-excites to the level M, leaving the molecule in an excited state, and the scattered line would have less frequency. If the molecule was already in an excited state M, then when you see the scattered beam, it'll be at a high frequency, and you'll see the anti-Stokes component of the Raman scattered line. This is possible only because there is an intermediate virtual state R of the molecule to which both the states M and N can connect through all the selection rules of radiation. A Raman effect cannot be explained classically, whereas Compton scattering is possible to be explained classically because it's billiard ball kinematics. But Raman effect, there is no classical analog of the Raman effect. Now, in the following months, how much time, when did we start? And so another 25 minutes? So during that year, from February 28 to January 29, they wrote 14 papers. Now, 4 of them are under joint authorship of Raman and Krishnan. And another 8, which make it 12, another 8 were written by Krishnan alone. But the 2 papers which appeared under single authorship of Raman, the first one is called A Change of Wavelength in Light Scattering, and it was sent to Nature on March 8, 1928, sole authorship of Raman. It's called A Change of Wavelength in Light Scattering, and this is known as the discovery paper. The second one is Raman gave a talk on March 16th in Central College, Bangalore. And this talk was transcribed by him and immediately printed as a paper of the Indian Journal of Physics, which Raman again edited. And he saw to it, preprints were available before the actual journal came out. And this, about 500 copies, were distributed all over the world on March 31st, 1928, so that people got to know. Now, this paper of change of wavelength in scattering had this line at the end. Preliminary visual observations appear to indicate position of the principal modified lines same for all substances. Krishnan saw the paper, the proofreading stage, or even after, and he told Raman, this is not correct, Professor. Compton scattering, you get the transverse scattered beam at 45 degrees, the difference in wavelength is a universal constant, h over mc. So it will be same for no matter which gas you scatter from. This is because of the molecular structure and their different vibrational rotational levels, and you're exciting different things. So you change the substance, the scattered beam will have a different pattern. Well, that's where it stood. It's still there. And I've seen a copy.
Nature paper?
Yeah. I've seen a copy where someone tried to scratch it out. I couldn't locate it. I wanted to also have the same kind of scratched out. I couldn't locate it. I think it's Professor Raman Session or somebody who's tried to scratch it out later stage. So Raman did not understand it fully, and because of Compton scattering and his thing with that, he did this mistake. Soon after that, on March 22nd, Krishnan and Raman sent a third paper, again Compton. It's called The Optical Analog of the Compton Effect. And it was published in Nature. That has the correct interpretation of Raman scattering. And then they, of course, wrote this very lengthy paper in Proceedings of the Royal Society, where all the spectra of scattered beam and so on. And so that's the story of Raman effect. On July 28th, there was an ad in the papers that Dhaka was looking for a reader in physics. And Raman asked Krishnan to apply. Krishnan was hesitant, but Raman continued. And Sukumar Sarkar was a Pali scholar then under Raman. Raman told him that he's a good friend of Krishnan's, both around the same age. They studied MSc together. You tell Krishna Iyengar that two great men should not work under the same roof. Krishnan heard it. But more than that, he came to realize in the entire excitement from February to later in the year that he was still playing the second fiddle. He was an assistant of Raman's, and he didn't have any independent status as a scientist. To come to his own, he had to get out of Raman's orbit. Second thing was, he had very high regard for S. Bose. And he thought proximity to a scientist of his caliber would improve his theoretical knowledge of physics. So because of these two reasons, he also heard that Raman had already, now we have, of course, hard proof of it. Raman already contacted Bohr and Rutherford, asking them to nominate him for the Nobel Prize. These letters are preserved in the American Institute of Physics. When he wrote to Sommerfeld, please do, Sommerfeld said, I have already done. So Krishnan decided to leave Raman's laboratory and arrived in due course. Raman was on the selection committee. Selection was just a complete excuse. I mean, all knew that once Krishnan applied, the other applicant, Satish Kastogir, had no chance. So Krishnan arrived in Dhaka as a reader in physics. So this picture is in the poster. It's a very famous picture. It's in front of Curzon Hall in Dhaka. Krishnan, far right, S. N. Bose, Raman, J.C. Ghosh, the first vice chairman of Indian Planning Commission, who is responsible for creating this institution called Indian Institutes of Technology. After he relinquished the directorship of IASC in Bengaluru, he went to Delhi and he did that. That is J.C. Ghosh, a chemist, Raman, and center is Professor Langley, who was the vice chancellor, a very well-known philosopher of his time. Okay, in Dhaka, Krishnan decided to leave Raman's scattering altogether and enter a new field. And this is magnetic properties of crystals and metals and so on. And he wanted to study two or three things of this. Crystals or they have three magnetic axes in X, Y, and Z. And you can define the magnetic susceptibility along these three axes. It's called the magnetic ellipsoid. Now, there are crystals which are uniaxial in the sense that the magnetic susceptibility in a plane, they're planar molecules or crystals, is almost the same, whereas perpendicular direction, the magnetic susceptibility is very different. So the difference is called the diamagnetic anisotropy, and Krishnan wanted to study this in very great detail. And there's an old technique of determining this called the torsional oscillation method, and Krishnan modified it into something slightly different, and it became known as critical couple method, which is very accurate, where you could measure the anisotropy of crystals as low as a few milligrams in mass. Is that accurate? And he used this, and this thing came to be known as Krishnan balance. And it was still there in whenever 1990s I visited Indian Association Cultivation of Science, where Krishnan later came. Krishnan balance was still there. So the thing is, because of his training under Raman, he learned how to use simple and ingenious techniques, locally available material to rig up highly sensitive scientific equipment. And this was later commented upon by another great low temperature physicist, David Schoenberg of Cambridge. He said this called the sealing wax and string method, which had gone out of fashion after Professor Rayleigh, Lord Raleigh's experiments. People were going for bigger and bigger kind of setup. So how cleverly Krishnan made use of the sealing wax string idea. And mind you, this was happening in 1930s. Literally, basic equipment was a fine quartz fiber and some shellac, the sealing wax, with which the quartz fiber could be attached to a torsion head at one end and to the crystals at the other. So these research, and he had several very brilliant students under him, they published some 6 papers in the Philosophical Transactions of the Royal Society. And according to Kathleen Lonsdale and Homi Bhabha, the papers were the foundation stones of the modern fields of crystal magnetism and magnetochemistry. A short note here, after Bhabha died, amongst his papers were found this biographical writing on Krishnan, which Royal Society had asked Bhabha to write. But before Bhabha could send it, he died in a plane crash. So Dame Kathleen Lonsdale, who was as close a friend and as great an admirer of Krishnan's, finished the rest of it, and this got published in 1967. Okay, so I must mention of the several great students that he had. The first one was one Bhagavati Sharan Guha, and Alok and I have both been his students in University College of Science, where he taught magnetism and he taught magnetism to Chanchal Majumdar, about which he has written. He taught magnetism in our MSc classes for maybe 30 years as part-time lecturer. And the other famous student was Akshayananda Bose, we call Akhay Bose. He founded the Cryogenic Council of India and did excellent work in low temperature physics. So in early 1933, whatever till then Krishnan had done, both, there were 2 parts. One was Raman's scattering papers, and the other part was this crystal magnetism paper. So he submitted a thesis again to University of Madras for the DSc degree, and within 6 months he was awarded, and he had very illustrious examiners, Richardson, Bragg, and so on, the older Bragg. And he was planning to go to Cambridge because he realized that he had enough of room temperature magnetism. But to see the real magnetic properties of matter, one had to go to very low temperature where thermal effects are very much less and you can actually see the magnetic properties. So he wanted to go to Mount Laboratory and applied for a Carnegie Fellowship, which is tenable in Great Britain. preparing when his whole plan was turned upside down, and again by his own guru, C.V. Raman. So in 1932, Sir Martin Foster, who was the director of IASC, Bangalore, retired. And they're looking for a replacement, and everybody's attention turned towards Raman, a Nobel laureate and very eminent scientist. He should start a department of physics and be the director of IISc. But Raman took leave for 1 year from Calcutta University and joined IISc. I wanted to see whether it suits him. In the meanwhile, he also wanted to retain control of the Indian Association for Cultivation of Science, because he had built it from scratch to a position of eminence, and he wanted that to stay. So he had to devise something. He had some money from a donor. With that, he established a professorship, and he wanted Krishnan to be invited to that professorship. So what he did is this: institution of Mahendralal Sarkar chair and Krishnan's appointment. This was in a meeting in 1933. And it was chaired by Sudhanshu Banerjee, a geophysicist or a physicist who was the first Indian Director General of Observatories. And he was the vice president of the managing committee. President was Sir R.N. Mukherjee of Indian Iron and Steel, Burnpur. Mukherjee had sent in his resignation, and this was accepted. By then, Raman had already co-opted his wife and his elder brother, that is Chandrasekhar's father, as members of the managing committee, and they were present. So his elder brother and one Rama Pai proposed Raman's name as the new president, and Raman immediately proposed Krishnan's name as the new secretary, because Raman was until then secretary of the managing committee. So with this, these two moves, he ensured his full control over the association. In the same meeting, names of Shama Prasad Mukherjee, his brother Rama Prasad Mukherjee, and the chemist Gyan Mukherjee were proposed for new membership, but the proposal was voted down. At that point, 2 members of the managing committee left the meeting in a huff. But Raman didn't stop at that. He wanted to make some permanent changes in the statutes of the Indian Association so that everything was under the control of the managing committee. There was a thing called life membership of the association, which was outside the purview of the managing committee. He wanted to change that. And he proposed certain changes, and there was a meeting. That meeting took place in 1934, June. But within this period of 1 year, a lot of bad blood was created in the Indian science scene, because Meghnad Saha and Lewis Fermor and Agarkar had proposed an Academy of Science under the aegis of Indian Science Congress Association, which will be located in Calcutta. So Raman preempted this whole thing by going directly to the registrar's office in Bangalore and registered Indian Academy of Sciences. So when the statutes change came up in the June 34 meeting, Saha and Shama Prasad Mukherjee had done some groundwork so that this whole thing was voted down. In fact, some 300 people suddenly showed up, and Raman said, in my 25 years of association with this association. I'd never seen them. Where were they? But they suddenly showed up on that day and they voted Raman's statutes down, and Raman was forced to resign. And Krishnan was retained the Mahendralal Sarkar chair, but his administrative and other things, editorial work at the Indian Journal of Physics, all that was taken away from him. Good, because those 9 years that he spent from 1933-34 to 1942 were the most productive of his career. And he and Akshay Bose finally managed to create the first cryostat in the country. And from the sealing wax and string mode, they moved in the so-called project mode, where they had to interact with industries, big companies, and develop bigger machines, because a cryostat is not such a simple machine. And they had this Magnolia ice cream factory at the disposal, where they used their oxygen liquefier and so on. And they could measure things up to 90 degrees Kelvin. The main interest of Krishnan, may I have some 10, 15 minutes more? 15? Okay. His interest was, Krishnan's, in the graphite molecule. The graphite is a crystal which has a planar structure. It has carbon atoms which are arranged in a hexagonal ring, and they are stacked up one another, up one above the other. Now, the magnetic susceptibility in the plane is rather low, but the magnetic susceptibility perpendicular to the plane is very high. And the difference, the diamagnetic anisotropy, as a result, is quite high. And Krishnan wanted to study this at lower temperatures. And now the graphite, each carbon atom is bonded to 3 other carbon atoms, but the 4th electron in the outer shell n equal to 2, is left free. So the graphite crystal is a planar conductor, because he has all these free electrons moving around, and current can pass through. But at the perpendicular direction, it is an insulator. Now, normally, there's a Curie law which says that susceptibility is inversely proportional to temperature. And it's true across the board. But when it was applied to metals, it's found that the magnetic susceptibility of metals is much lower than what the Curie law at ordinary temperature will indicate. And Pauli immediately said the electron gas in metals degenerate. You cannot do classical statistics. What was done to derive Curie law, it should be quantum statistics. And applying Fermi-Dirac, he derived the correct formula, the Curie law, where the inverse proportionality was to Fermi temperature. Now, the Fermi temperature of metals like copper and silver and so on are in tens of thousands of degrees. I think 64,000 degree in one case, 82,000 degree in another case. So in ordinary temperature, they're always degenerate. So when you measure, the values are extremely low because it's inversely proportional to TF, which is so high. And the values don't show any change, because almost independent of temperature is the diamagnetic anisotropy. A little bit changes there because of what is called the crystal fields. So, but for graphite, Krishnan saw that even in ordinary temperature, we find the validity of Curie law. Then he said, then maybe if we go to lower and lower temperature, then finally this effect of electron degeneracy will show up. And this was the motivation to make this cryogenic experiment, the cryostat and so on. And when the cryostat was finally made, they made one, Ganguly and Krishnan made these measurements. And you can see that at room temperature above, that's the Curie, where is the pointer? Oof. No. Where is the pointer? Not this. No. Anyway, it's going down with temperature, but then it sort of levels off. And that is the theory of diamagnetism in a degenerate gas that Landau had worked out. And this was the first, I think, proof of Landau diamagnetism in experimental physics. And it's a very beautiful experiment. And Krishnan's paper is a landmark paper on this. So in 1940, he got the fellowship of the Royal Society. It is the fifth Indian to be so honored after Srinivasa Ramanujan. After Ramanujan, it was J.C. Bose in 1920, Raman 24, Meghnad Saha 27, and Birbal Sahni 1936. And just 5 more minutes. In 1938, Meghnad Saha left Allahabad and came to Calcutta as Palit professor. And there's a strong rumor that the professorship at Allahabad will be offered to Krishnan. Krishnan thought about it and without any, wrote to Raman saying that, should I take if I'm offered? So Raman said, no, I don't think you should take it. And stick to your present position, which I have not added. He also said, I'm going to retire. And after my retirement, the current position I'm holding is all yours, meaning directorship of Indian Institute of Science. So you stay another 10 years there and so on. So 2 years had gone and Allahabad had to find a professor. They appointed a selection committee. I'm only saying this because I don't think it has ever happened in the history of Indian universities, what follows now. The selection committee had A.N. Jha was the vice chancellor, S.S. Bhatnagar, and C.V. Raman. And C.V. Raman said that he had heard that Schrödinger is in deep trouble, and I offered the Central College professorship, but because of low salary, it didn't come. So we should have Schrödinger. And they drew up a list of possible candidates. And that list, number 1 was Erwin Schrödinger, number 2 was S Krishnan, and number 3 was Subramanian Chandrasekhar. I don't think ever such a list has been drawn up in any Indian university ever. So there's a strong rumor that Schrödinger will come, but Schrödinger didn't come. And I should perhaps explain my telegram is the result of an inquiry whether you'd be prepared to accept if for some reason Schrödinger, the appointment fell through. Then he said, actually this morning's papers announced they have appointed Schrödinger. I have that clipping. It came out in Madras Mail and the Hindu, that date, 28th April 1940. But Schrödinger never came. So then when Krishnan was offered, he immediately said no. Then Chandrasekhar, he said no. In fact, he kind of enhanced or whatever thing with the university by sending a letter from Otto Struve, who was the director of IACS Observatory, to C.V. Raman, saying that no matter what, we will not spare Chandra because he is doing great work and we need him. So Chandrasekhar, then came the next thing. Raman said, Homi Bhabha. And Bhabha writes this letter, 20th May 1941, to Krishnan. Should I take it? And Krishnan gave the same and then Bhabha says, I'm not really interested in teaching. I want to do research, develop a school where, etc., etc. So I'm really not interested. He was a reader in physics in Bengaluru at that time. Bhabha refused. So
was offered?
Oh, of course. He offered and he immediately refused. That refusal I don't have. Like Chandra's refusal I have. So 2 years had gone and 38 Saha had left. 4 years had gone since he left. Chair was vacant. So then they again offered to Krishnan. And this time other matters helped. Calcutta was under threat of being bombed by the Japs, and they wanted to close down the laboratories at the Indian Association. And they said to Krishnan, we are taking it to some place and keep it in some basement. And Krishnan fought very hard, but they didn't relent. So with his laboratory gone, and so on and so forth, he decided to go to Allahabad. So
1943.
42 end. 42 went till 47 he was there. And then in 47, by then he became very close to Nehru and so on. And this National Physical Laboratory was coming up, and he was both Nehru and Chakrabarti Rajagopalachari, who knew Krishnan as a friend in a different field, Vaishnava philosophy. Very great, close friends. So he was the minister, no, he was the minister of industries or something. So you must take it. Krishnan moved. And he stayed in NPL till 1961 when he suddenly died. There were some other little things about how he set up the low temperature laboratory in NPL and how he failed to do radio astronomy in NPL, which Bhabha had to do some 6 years later, 56. He tried very hard before Govind Swarup left NPL to go to Stanford because he couldn't get those 32 1.8 meter dishes from Australia that Posse was offering to India, free of cost. He couldn't get the government to pay the transfer shipment charges. So Govind got very upset and he left for Stanford. That was the end of radio astronomy efforts in NPL, and only in 1962 things could start in TIFR, and Govind and Menon and Kundu, they all came together. I just want to close with one, because people have often asked me that you write this is the first flask of liquid helium produced in. Then he was a chairman of the IGY, and he did excellent job coordinating the Indian effort. This what Sidney Chapman said. And this is the last thing, because people have often asked me, you've written this book, seems like there's nothing wrong with him. He was a great guy. It's only, hagiography or whatever it's called. Where is the thing? Then I said, well, here is the thing. This is a statement that Sarojini Naidu made in 1949 to Krishnan in Indian Science Congress, which took place in Allahabad. He says, less than a month ago, I gave you a very valuable piece of advice, which I hope you have taken to heart. Had so much praise in your life that I think my piece of advice was very timely and very practical. You've done wonderful work for many years. You've labored for science with a disinterested love and with great ability. And your work has brought you great fame. But I've seen with dismay as well as pride one great fault. You are too modest and too unassuming. And in the case of science, you must be arrogant, which of course C.V. Raman is the epitome of. Do not believe that being assertive in science is being conceited yourself. Your work will live, and I wish you great success. But do not let me have to remind you a second time, hold up your chin and face the world, because you've brought a message for the world. I close with that. There's one little thing which I didn't put. S. Venkateshwaran, who was one of the 3 or 4 students of Raman in Calcutta doing the same experiments on scattering, he wrote a letter in 1947, and we have that letter. And he ends with, it's amazing that in my life I've gone around in such close proximity with great people like C.V. Raman, K.R. Ramanathan, etc. But what remains in mind is the self-effacement of a truly great man. He wrote this to Krishna. So the self-effacement, the same word that K.R. Narayanan used in his Krishnan centenary meeting, which kicked off in Nias in 1998. He said, merger of your ego with somebody else's. Merging of your ego. So, okay, thank you. I'll be happy to.
As expected. Fantastically engaging talk. It looked like as if we ran through Krishnan's life. I remember long ago, I went to a university called Kalasalingam University, which happens to be very close to the place where we were to set up our observatory. And I saw a tall statue of not any of the well-known scientists, but S Krishnans. I didn't really understand. It's largely an engineering college, and of course, it had many other disciplines there. But why S Krishnan's statue was, so prominently put up in front of their mathematics department?
This was in Madurai?
This is Srivilliputtur, so that's where I'm coming to.
Srivilliputtur, of course.
So then when I kind of asked a mathematics professor, who had incidentally connections from TIFR.
Right.
So he said, oh, you don't know, S Krishnan is born in this place.
Oh.
So your
not
talk,
quite there, but a little bit off.
Yeah, your talk reminded me of that incident. And wonderful. So are there questions to Professor Mallik? Yes, yeah, go ahead.
You mentioned Govind Swarup and NPL. Krishnan also had put Govind Swarup as a secretary of the Radio Research Committee.
That was later. At the time we are talking about, I think secretary was S K Mitra. Krishnan was the president. Govind worked for a year in NPL and then went to CSIRO.
Yeah, but when this was happening, he was in touch with both Meghnad Shah and S.K. Mitra.
S.K. Mitra, yes.
Yeah,
S.K. Mitra was his, almost his colleague, yeah.
So can you say something more about this? Or it's something more known about this?
I have
records of it?
No, I have not explored the relationship between Saha and Krishnan, excepting when Bhabha sent Krishnan to review the work in the Institute of Nuclear Physics, Calcutta, which Shah was heading. Bhabha sent a review committee from the Atomic Energy Commission because Department of Atomic Energy financed Institute of Nuclear Physics, and Krishnan was the chairman of that committee. And Krishnan went to Cal. And some reports are there, where one of Krishnan's main grounds was, see, in NPL, if you look, we have people from all over the country. In your institute, I only find Bengali names. So this was, I remember this because this took place in a conversation when another person was present, and he now dead. He told me that this is what Krishnan said. Tell me one thing. Are there any other people in your thing other than from West Bengal or other than from Bengal? And Saha had no answer. I know of only one guy, B.B. Baliga, who taught maybe holocaust to both of us. He was not Bengali, but naturalized Bengali, having lived in for several generations. Otherwise, not a single guy then.
And can you say something about Krishnan's diary, which you have referred to in your book or in another paper published?
Krishnan's diary is a very sordid story. I don't want to really get into this. Krishnan's diary was taken away minutes after his death from his son. And his son was by K.R. Ramanathan, and son was deeply indebted to Ramanathan. In fact, the whole family, they're all Tamilians, and they called K.R. Ramanathan Periyappa. Krishnan was Appa and he was Periyappa. So those who know a little bit of Tamil would know that to call somebody Periyappa, I mean, he is the patriarch of the family. That's the status Ramanathan had. So when he asked Krishnan's son, Ambi, can I have that diary your father wrote? Ambi probably was the only person who knew about it, and he gave it. Nobody knew. None in the family knew. Krishna's other children didn't know. Nobody else knew. And suddenly one day, the excerpts from the diary appeared in Current Science. Krishnan died in 61. Raman died in 1970. I'm talking of 1971. Excerpts started. Then this, my friend Vijayaraghavan Tiruvadi, he was a grown-up man. Then he asked Ambi, where is that diary? Where is that diary? How does it appear in? We don't know. So Ambi said, I've given it to. So from then till the time Ambi died in 1999, I think, or maybe 1998, he carried that guilt in his mind that he gave it without letting other children and so on know, because he knew the importance of the diary. So then he went out of his way. By then, Ramanathan was dead. Went out of his way to go to Ramanathan's son and say, your father took it away from me, can you give it back? And after a lot of prodding, one day this thing came in an envelope to Ambi. Ambi opened it and he found something amiss. He gave it to our friend Vijay Tiruvadi. Said, Vijay, this is all I could recover, but I don't think this is what I gave. I don't think what I'm giving you is what I gave Ramanathan. That are exact words. So Ambi surely had read it. So the crucial moment on February 28th, that is when we decided to use monochromatic light, no full stop, nothing. Pages are torn and it's only 15 pages are left. They are in NCBS archives now. They were with me all these years. Handwritten, pencil written. And a lot of scratching and corrections, which either Ramanathan or Raman or somebody had done to scratch out things, which I have included in but the lost pages I have not included. I don't know about. I'm sure they're somewhere. It's a sordid story.
Okay, so are there any questions from Zoom? Okay. Yes, sir, please go ahead.
Can you hear me?
Yes.
Okay, my question is, how did Krishnan react to the Nobel Prize being given to Sir C.V. Raman?
We have no direct, he must have enjoyed it, he must have loved it, he must have said congratulations. We have no direct proof of it, but I don't think he ever resented that particular thing. That's not the point. Raman getting Nobel Prize, great thing for India and Raman and so on.
Any other questions? Okay. Not would like to thank him.
Thank you. Thank you.
Very. So we'd like to give you a small token memento of asset, which is very special for us because this commemorates the 40
very much
years.
for a spellbinding lecture which you gave.
Wow.
This is a moment to remember.
Fantastic. This is where this.
This is in the Qutub Minar.
Qutub Minar. Okay.
So this is our kind of iconic
Okay.
picture representing asset and its.
Thank you very much. Thank you very much.
Thank you. Thank you very much.
Ready to join for it.
Okay.
Yes, everybody can thank you.
Oh, okay.